Hello everyone, welcome back to Power System again. This is lecture 5, part 3. In this lecture, we're going to talk about power transformers. So power transformer is an very essential, is a very essential part of the power system network. You need to step up voltage at the generating station right here. So there's one transformer here stepping up, then you go through all the transmission line, stepping up, stepping down. When you come to your neighborhood, finally you have to put it down to 120 volts here. So all those voltage level changing happens due to the transformer, and this is very essential too. So when I see a transformer, inside the transformer we have a coil, right? We have coils and also a magnetic core. So there, in the modeling, we have an ideal part of the transformer, which is this one over here. This is the ideal part of the transformer. There's no losses, nothing. But we have winding on the both side, which is a coil, primary and secondary. So the two means secondary, one means primary here. So that in the winding we have resistance, which is R2, and also winding has an inductance, and we have inductive reactance here due to leakage flux. And also magnetic core, which is a ferromagnetic materials, magnetic core has also inductance and resistance in the core. So what are the purpose of the core here? The purpose of the core is to produce flux. We need flux to link to the coil to induce voltage. So this coil, this core over here, produce flux. To produce flux, we need a little bit of current. That's why I0 is there. If you remember the equation from physics 260, that your magnetic flux density is mu I over 2 pi r, if I'm not mistaken. So here, you can look at that. This current, you need current, and also permeability. That depends how much flux coming out. It's the flux density, right? So if you have high permeability materials, you need little current to produce flux. That's why we use ferromagnetic materials, which is high permeability materials, to produce flux. When that flux produced from the core, that flux will link with these both coil over here. When it's linking, then they'll produce voltage, induce voltage, using this equation over here. Right? So that means only things over here, and is a turn number. So only thing will define the voltage level is basically turn. So that's why if the flux is here, if you use that equation, you will get to this over here, right? And that, and also second coil is right here. So only difference happening due to the number of turns in the coil, all right? So that's how you get the voltage in two different coils, which is flux produced in the core. Again, as I said, there's resistance. There's also inductive reactance due to the leakage flux into the coil, and that is right here. So this is your transformer model as it is, primary and secondary. Again, one is primary, two is secondary. So now also you have this equation here, and also in the secondary, if you look at this voltage over here, it should be this voltage plus loss over here, this equation right here. And this equation over here, this part of the equation over here can be changed like that. And the current relation also goes like that. So there are three equations for the transformer. Now, if I combine these three equations together, I'll get to this equation over here. All right? So if you look at here, E1 right here, right? E1 right here is depend on this N1, N2, V2, and N1, N2 square, Z2, I2 prime. I2 prime is right here, okay? So then if you combine that, I said V2 prime, all right, Z2 prime, I2 prime. And what are these? Z2 prime over here is R2 prime plus JX2. That means you have N1 over N2 is turns ratio squared times R1, that will give you R2 prime. So, and X2 prime is N1 over N2 squared times X2. What is this called? So R2 prime is the secondary resistance referred to primary. So it was in secondary instance, I'm referring that to the primary, that's what is R2 prime. So now, if you look at this diagram over here, there is no secondary anymore. Everything in the secondary was referred to the primary, right? And also your voltage, current, everything is referred to the primary. So whole transformer now referred to the primary. Okay, there is no secondary anymore. So this is basically the prime, G2 prime is whole impedance referred to the primary, and I2 prime and V2 prime, that's everything go to the primary now. All right, so now this is the circuit you have seen the last, what do you call it, in the last slide. So now this portion over here carries a little bit of current, so I can move that to the left, all to the left right here, then I can add these two together, that's right here. So now, so RE1 is basically you're adding R1 with R2 prime. So R1 with R2 prime is RE1. So that's the equivalent resistance to the primary. And same to XC1, you're combining X1 plus X2 prime. So that is equivalent inductive reactance to the primary. So that's right here, right? Now, so if you're trying to find V1 over here, which is primary voltage, that is V2 prime right here, plus whatever losses in the equivalent resistance, right? So that is all, this equation will give you voltage referred to the primary. And this also, this equation over here will give you the I2 prime in terms of your complex power and voltage in the secondary voltage referred to the primary. So now, if you do the same thing to the circuit to refer to the secondary, then you'll get V1 prime here would be V2, because you don't change anything here, and R2, RE2, and XE2. What is RE2 here? It's basically R2 plus R1 times N2 over N1 squared, right? And what is XE2 here? Is basically X2 plus X1. Now you look at it, your ratio is changed over here. It was N1 over N2, now it's N2 over N1 squared. So that means you're referring to the secondary. So this equation over here will give you the voltage referred to the secondary. And this is the simplified version over here. This is the simplified version referred to the primary. This is the simplified version referred to the secondary. So why is simplified? Because we're ignoring this branch over here. As I said, this branch only carries a little bit of current. So we can ignore that. This is the simplified version of the transformer. So that's all. We're going to do this problem in the class, and I'll see you in the class soon.